Hi students, we're going to continue with the single-minute exchange of dyes by looking at the second phase, which is converting internal processes, IED, to external processes, or outside the exchange of dyes, OED. So the first example is a little bit confusing because it also talks about dyes, but in this one it was dyes for clothing, to change the color of clothing. And so this is an example that Mr. Shingo gives where the process had a large container that contained the dye mixed into water or whatever other fluid it was in that was used to color clothes. And when the company wanted to change colors, they would exchange, drain that old dye out, and they would put the new dye color in, and then have to wait a while for that to heat up. And it was on the order of hours that they had to wait. And so during that entire time, they're not dyeing any clothes. They're not making any money. And so the suggestion that Mr. Shingo brought was to purchase an external reservoir and heater system so that one could preheat the dye and then put it into the machine. So when we look at it from the outside, that seems obvious. A lot of times these do seem obvious in retrospect, but one of the real challenges is that there are new difficulties that are brought up by this process. One is the capital cost of buying a new reservoir and a new heater, but there are others in that now loading the dye from the preheater into the process tank has to be done with hot liquid, and so there may be some difficulties safety-wise as well that have to be addressed. So not always completely obvious when you're in the moment, but afterwards you look at them and think about the fact that this allowed them to change over very, very quickly and immediately be making product in a new color. Moving back to the original form of dyes, those that stamped sheet metal, one of the things that he often finds in companies for that or any fixturing type process is that there need to be extra racks right next to the process for preloading the equipment. And so if you're bringing fixtures over and you're bringing all of the parts of the fixtures, there needs to be a place that is set up to hold that and is ready to put it into the machine. One of the other things that he often found was that these items were big enough that they required a forklift. And so even if people were had worked out the need to have the new fixture ready outside the machine, they would stop the process and then go look for the fork truck to be able to lift the old one out and the new one in. And that was a very long process of finding the fork truck, bringing it over, lifting it out. Sometimes they had to also go find another person to help with the process, somebody to loosen the bolts or guide them as they drove the fork truck. And so one of the processes was also developing these racks such that they allowed for loading the machine directly without requiring the use of a forklift. And that allows you to bring things over when the forklift is available. You bring over the next fixture that you're going to need, get it all set up on the rack, it's already preloaded, and then as soon as the process goes down and you take the old fixture out, you can slide the new fixture right in straight from the racks, can get the process running with the new fixture, and then worry about going to get the forklift to take away the old fixture and to get whatever the next fixture is going to be. There was a system for that required vacuum, and so I'm not sure if this was a composite system or not, but anyway, it required that something occur and then vacuum had to be pulled on the process before they could run, and it might have been a molding system also. And so what he suggested is instead of closing up the mold or getting the process all ready and then turning on the vacuum pump and waiting for the 10 or 15 minutes while it pulled vacuum, you could have the vacuum pump running all the time and have a big tank. Has to be a vacuum rated tank, of course, but you have a big tank and you pull pressure or pull vacuum on that big tank ahead of time, so it's just sitting there pulling down. And then as soon as you are ready to run the process, you can open the switch that connects to that tank, and it will pull off a large amount of the atmosphere that was in the system. Now, you probably still have to run the vacuum pump some to get the final amount of vacuum that you need, but it allows the presetting of vacuum. You can do the same thing with compressed air if your process requires compressed air. Fill a tank and then have it come straight from the tank rather than from the air compressor. And so it's interesting because we wouldn't ever consider not having a compressed air tank there to have air available, but vacuum is a little less intuitive somehow. And then one where this was a stamping process that uses huge rolls of stock. The rolls of steel were very heavy. They required a fork truck to bring them in. And so in this process, he took the reel that was in process that was being used, and then whenever the fork truck was available, they could bring in extra stock. They put it on a system where the stock could roll into place without the use of a fork truck, and even were able to somehow weld the end of this reel to the beginning of that reel so that the person didn't even have to be there to feed from one to the other. I don't quite know how they do that, but anyway, in one of the operations with a spring steel wire, they were able to do that. Okay. Now, one thing that this can lead you to is a really bad idea. And so that really bad idea is size standardization. Often when people start to do this, they say, well, what we really need to do is, all of our dies or all of our fixtures ought to be exactly the same size, because the easiest way to go from fixture 1 to fixture 2 would be if fixture 1 is exactly the same size as fixture 2 and we don't have to do any additional adjustments or efforts. But the problem is then you're buying huge fixtures for everything that could have used a small fixture, and there's only one process that needs the big fixture. And so then you have unoptimized, you have de-optimized, I don't know what the word is anyway, you have sacrificed optimization of size for every single process just to fit one. But there are other ways that you can do this. So this is a process where they had die A, this was again a sheet metal stamping die A, and die B. And A was much thicker than B. And so when you go from A to B, it requires resetting the height of the stamping dies. So you have these platens that are coming together, and if they come too far together, they will hit and it will explode the die. And if they don't come together far enough, if they stop short, then the part won't be totally formed. So it takes some effort to adjust these. It's a little bit less effort now in the age of servo-driven, computer-controlled dies, but especially if you're using hydraulic dies, if they're big enough and they're hydraulic dies, this is a real issue, and it's very difficult to deal with. And so instead of making everything much larger than you need it to be, you can do this. You can do functional standardization. And so you divide the operation into individual functions and you replace the fewest and smallest parts that you can. And so in this example, what he does is he makes these little blocks that are the height difference between die A and die B. And when you're using die A, you put those blocks on top of this bottom flange, and then the dies are set at this 320 millimeters, and your clamping occurs at 80 millimeters up. So you clamp them right there, and then the die is set to run at 320 millimeters. But when you use die B, you take shims that are 50 millimeters, the same shims, and you put them underneath the die So now you are still closing up on 320 millimeters and you're still clamping on 80 millimeters. And so what this allows you to do is to use the same two dies with exactly the same setup in the machine, but not having to lose the optimization that you had in the size of the dies. Other things that you can do is if you have an arm that position parts, only change out the very end effector of the arm. Don't change the whole arm. Don't go get a whole new robot, put a new end effector on it, end of arm tooling. Or other things like making all the bolts the same size so it uses one wrench to do everything. Now, that's not optimum because you could use smaller bolts that are not as strong in a lot of cases. But if you're able to do that and it makes sense, then you only have to have one wrench available. You can make sure that that wrench travels with the die or with the fixture and is ready for it. So if you were thinking back to our CNC classes, can you think of OED processes that we did as IED? So I'd like you to think about that a minute. Okay, so I think there were actually a lot of them. Some of them you dealt with and some of them you didn't deal with very much. But we put, if you remember, we took the blocks that we were going to machine and we put them in the machine, and then we measured from the back of the vise to the top of the block. Well, we zeroed on the dowel pin and we measured the height from the back of the vise to the top of the part, right? And we had chosen a set of parallels to go in there to put this on. Well, none of that had to occur in the machine. We could measure the stack up height of the parallels and the part outside the machine, and then knowing that number and knowing where the bottom of the vise is, we could just enter that number on the controller, put it in the machine and be ready to go. Another thing that we did is we put our tools into the machine, and then we went in and we touched off all the tools on the dowel pin. So that was all set up, that was being done inside the machine. Now we do that for a couple reasons. One is to help understand tool length offsets, but another one is because tool setters are very expensive. But there is a machine that you can get where you position the tool in the tool holder outside the machine. You come in and it touches or measures optically the top of the tool, and it tells you a tool length for that tool in its holder. And so instead of going into the machine and setting those numbers, all you do is type the numbers into the tool table on the machine. One that you also didn't have much to do with is the process of setting up the fixtures, and we'll talk about that a little bit more in just a minute. So the last thing to do, well, actually we'll talk about that in the next video. So I will see you in the next video.